Hi everyone, my name is Devang, and in this particular video I will be talking about another data structure which is known as queue. Okay, so in the previous videos we talked about arrays, recursion, link, stacks, and some of the strings and all that. Now we will be talking about queue. This data structure is very helpful, and this is used in various things, such as this is used in buffers. Okay, this is using your routers, your Wi-Fi, your router, your network devices. This is used in various things. This is used to synchronize things. What do I mean by synchronize things? When you type anything on your keyboard, firstly it goes onto a buffer, then it's come to your CPU, your monitor. Directly does not comes to your monitor. The speed of monitor and the speed of keyboard are different. Both of them are having different speeds. So to synchronize the speeds between them, this kind of a thing is used, which is known as queue. Now this data structure has various many application in the problem solving also. Like we are having a technique which is known as sliding window. Now this sliding window concept is based on the data structure which is known as queue. The BFS, like the breadth first search can be done on the basis of queue. This queue is very important because this will be used in trees, this will be used in graphs, and will help us to solve many problems. So without wasting any time, let's dive it into the queue data structure. So first of all, let's understand what is a queue. What is a queue? Okay. So to explain you this, let us see a story. We have a doctor. Let's name it Dr. D. Let's name it as Dr. D. Okay. And this doctor has a clinic. It has a clinic. Like, let us draw its small clinic. Yeah, so this is his doctor's clinic. Now we have patient. Let's say that this is the patient one. Okay, let us draw the patient one. This is the happy patient. So this is patient one. Now this patient one arrives and comes to the doctor and and says that, hey doctor, this is my condition and I want you to analyze me. Okay, now another patient comes. This is the another patient. This is named as patient 2. Now he waits until this patient gets his things done by the doctor. Now this patient 2 waits for P1 to finish its appointment, or its task. Let us call it as task, to finish its task. Now another patient comes, P3. It stands the line. This is a line. It stands in the line to get its checkup done. When patient P1 leaves, let us just mark it by this color. When patient P1 leaves, patient P2 will arise. Patient P2 will come to doctor and say that, doctor, hey doctor, this is my condition, kindly help me to just cure. When the P2 overs, P3 comes. So you can see that what was the order in which they arrived. What was the order in which the patient arrived? It was like, first of all P1 came, then P2 came, then P3 came, right? And the order in which they left, that order is somehow P1, P2, P3. That means firstly P1 left, then P2 left, then P3 left. So this is the order of the queue. This is the order of queue. Or you can say that queue is a line. Queue is a line in which the elements are treated as first come first serve manner. Now this has a more good term. This has a more good term, but before that, let's understand this term, first come first serve. Now this patient come first, it will be served first by the doctor. This came second, so it will be cured secondly. It will become third, so this will become cured third by the doctor. Now this kind of order is also known as FIFO order. This kind of order is also known as FIFO order. What do I mean by FIFO? FIFO stands for first in first out order. First in first out order. Okay, let's understand this more deeply. I said the queue data structure is having FIFO order. FIFO order. It means that it is having first in first out order. First in first out order. It is totally different from that of stack. If you remember, it is totally different from that of stack. In stack, we are having an order of LIFO, which means last in first out. Last in first out. Whereas in the FIFO order, we have first in first out. That means if we have element A which comes first, it will be processed first. Element B comes after element A, so it will be processed after element A. Element C comes after element B, so it will be processed after element B, which will be processed after element A. So this is known as FIFO order. Okay. Now we understood the concept of FIFO order. Now let's try to analyze the concept of queue data structure. How do we represent it? How do we represent it? To understand this, we can represent a queue with the help of vector, with the help of array, with the help of linked list, But linked list is not much used as compared to array because of the much costlier operations of move and all that. So let's talk about array first. Let's think of this as our queue. Okay, this is our queue. Now, if this is our queue, so how can we say that it is following first in first out order? Let's say that I got this element A, so I will place it in this box. Let's call it as an index 0, 1, 2, 3, 4. So the size of the queue is 5. Okay, I got element A, I place it at the 0 index. I got element B, I placed it at index 1. I got element C, I placed it at index 2. I got element D, I placed it at index 3. I got element E, I placed it at index 4. Now when it's the turn to process, I will process the elements in this order. Like firstly I will process A, then firstly I will process A, then A will be gone, then I will process B, then B will be gone, then I will process C, the C will be gone, then I will process D, the D will be gone, I will process E, and E will be gone. So can you see that the order of queue is first in first out? It can be simply represented it can be simply represented with the help of arrays. Okay, with the help of arrays. So now we have understood the concept, like how queue works and how can we represent. Let's revise it once again. So imagine this to be your queue, 1, 2, 3, 4, 5, 6. So if I try to process the elements of this array, by the process I mean that output the array. So the output would be 1, 2, 3, 4, 5, 6. If the input manner is 1, 2, 3, 4, 5, 6. So this is the FIFO order. Okay, this is the FIFO order. Now let's try to analyze some things, like some important terms for the FIFO or for the queue data structure. Now first important thing is NQ. NQ means pushing an item into the queue. By push I mean that inserting an item. Okay, inserting an item. Now the second operation is DQ. It is not called DQ, it's called DEC, but we write it like this. DEC means popping an item from the queue. Popping also means deleting. Popping also means deleting. Now try to understand. Let me just rub this once. Okay. Let me just rub this one. Now try to understand how NQ and DQ will work. How NQ and DQ will work. Now let's say that I am given this queue. I am given this queue, okay, with these 4 boxes, and firstly I'm asked to NQ 10, QUE, NQ 10. Then I'm asked to NQ 20. Then I'm asked to NQ 30. NQ 30. Okay, let's NQ these items. So firstly 10 will come here, 20 will come here, 30 will come here. Okay, now I'm asked to DQ once. So what DQ will do? What do you think? I will just suggest you to pause the video over here and try to think like what DQ will do. I have told you that while we are using DQ will help to pop an item from the queue. It means deleting the item. So I already told you that we are following a FIFO manner. We are following a FIFO manner in queue. So when we will delete an item from the queue, the firstly inputted item, which is 10, will be popped out. Now when I will call DQ again, 20 will be removed. Then I will call DQ again, 30 will be removed. So this is the order of NQ and DQ. Okay. We are having more functions, which is first of all size. It returns the size of the queue. It returns the size of the queue. Okay. Then we have is empty and is full. Now these functions are readily available for all the data structure, but in the queue we also have some important term. Let us discuss that. Let's think like this is our queue. So not this. Let us think like more of the array kind of data structure. So in the queue, this is our front element, and this is our back element. So basically this you have to remember while you are considering the queue. When you are doing any operation, all the operations will be performed upon front element. Remember this. All the operations will be performed upon front element of the front element. Okay. Now let's think of like in this way. Like we would be having 10, 20, 30. I NQ'd 10 first, then I NQ'd 20, then I NQ'd 30. Now when I call DQ once, this will be removed. My queue would become 20, 30. Why? Because shift would be happening. My 20 would become the front element. When I call DQ again, 20 will be deleted and I will be only left with 30. So always remember that all the operations will be performed upon the front element only. Okay. And the back element is the tail. You can also call it as the rear end of the queue. Now why I am telling you the rear end of the queue? Let us see about that. We have different types of queues. Basically we have different types of queues. Now in that the rear is used, in that the back is used. The first is the same. The first is the simple one, which is queue, which I already saw. The second one is DQ. Now what do I mean by DQ? It is doubly ended queue. Okay, doubly ended queue. Now in the doubly ended queue we can insert and delete the elements from both the end. We can insert and delete the elements from both the end. This is the benefit of the DQ. Actually it is called, like, if we are having like this is the front element and this is the back element of the queue. So what we can do, we can actually process in the DQ, we can actually process this element and this element also, So this is the benefit of DQ. Okay, and the third type of the queue which we are having is priority queue. Priority queue. Now we cannot discuss more about priority queue because it requires the concept of binary search tree, binary tree, and all that. We will discuss this in the next part of the video, but to make sure that you understand the priority queue, let me give you a hint. A priority is a queue in which each element is assigned some priority, in which each element is assigned some priority, okay. Now this kind of a data structure is helpful, like okay, let me just explain you once. Now this kind of a data structure is helpful when we want to maintain a chain of a particular order. Now what do I mean by that? Let's think. Okay, let me just write it down. Okay, yeah. Now let's think that we want a data structure in which every time I add element, the first element of the data structure is the maximum element. Like I add 10, so the top element is 10. I add 20, so the top element becomes 20. I add 5, the top element is still 20. It means that I want to maintain a data structure in which the top element is always the maximum element from the stream of the data which is available to you. So in these kind of a problems, priority queue is used. It means every element is assigned some priority. So I hope that you understand the concept of priority queue and all that. The real world application of queues are like doctor queue. When you visit a doctor clinic, the queue kind of a data structure, or when you go to a market, when you want to purchase anything, that is an example of queue. And as I told in the earlier part of the video, the synchronization, the networking part, all are the part of the queues. So I hope that you understood this video. In the next video we will try to implement and see the SQL representation of queue. So if you have any doubt, make sure you comment it out, and we will meet in next video. Okay, bye bye.